Hello everyone, let's solve question 30 of GATE paper CS1 2025. Let S be the set of all ternary strings defined over the alphabet A, B, C. Consider all strings in S containing at least one occurrence of two consecutive symbols, that is A, B, B, C, C, at least one occurrence. The number of such strings of length 5 that are possible is, I need to count that. So, in order to solve this question, it is a simple combinatorics problem, let's understand that. So, let's understand what a ternary string is. So, a ternary string is formed using three symbols A, B, and C. Let's say in this particular case. So, for a string of length 5, there will be uh, 3 into 3 into 3 into 3 into 3. Total 3 to the power 5, that is 243 cases. These are the total strings of n length is equal to 5, where a string is formed using three symbols. Here in our case, it is A, comma B, comma C. Now, once we know this piece of information, let's do that. Let's understand the complement principle, which is the inclusion exclusion principle. So instead of directly counting all those strings with A, B, B, C, C, let's do all this. Answer will be basically the total strings. Let's do that. That answer is equal to total minus string with no two adjacent character. Okay. So what we will do, we will count the string with no two adjacent repeats and subtract it from the total strings. We know total strings is equal to 3 to the power 5. Now I have to count strings of length 5 where no two adjacent characters are same. Let's do that. So let's start with positions. So let's say there are five positions: position 1, position 2, position 3, position 4, position 5. First place can have anything, 3. Second place must be different from position 1. So two choices here. Third place must be, let's say here we have A, B, C as options. So if I choose A, then here come B and C only. So if I start drawing it out, then A, B, if I start drawing it out, then A will come first, then B, and then C. So if A is at the first position, then the second position can have B and C. For if B is at first position, then second position can have C and A. If C is at position, then the next position can have either A or B. So you can see there are total three options here. Then two options, two options. So I'm trying to say that there are only two options here. Uh, so if I choose one of them, then other needs to be different. So two here, and two here. So total options will be 3 into 2 into 2 into 2 into 2. That is 3 into 2 to the power 4 is equal to 3 into 16, which is 48. Total 48 strings are there where no two characters are actually adjacent and matching. Okay. So total strings will be 243, 3 to the power 5 minus 48. That is equal to 195. So that is our answer. So the total strings with what we did, we calculated total strings and subtracted those strings with no two adjacent characters. So we got the strings with at least one pair of adjacent characters. Okay, so that's it for this particular video. The total answer is 243 minus 48, which is 195. That's it for this video. Take care. Bye bye. See you guys in the next video.